Hello everyone. Today we will learn about preprocessing textual data. This is a lengthy topic which cannot be covered in a single video. Therefore, we will divide it in several parts. In any machine learning task, cleaning or preprocessing the data is as important as building the model itself, as the reliability of the model is highly dependent upon the quality of the data. And when it comes to unstructured data like text, this process becomes even more important. This is because machines are not able to understand the meaning behind the text like humans do. And therefore, we need to encode text in a form suitable for machines to interpret by vectorizing it. But first, it is necessary to familiarize yourself with text data and to clean it by removing unnecessary information from it before vectorizing to obtain optimal results. So we will discuss all the steps involved in pre-processing text. Let's start. In this video, we will particularly focus on analyzing the textual data and familiarizing ourselves with the data that we are working on. So we will be working with a tweets dataset that can be used for sentiment analysis, and this data is hosted on a GitHub repository. This is the page on which the file has been posted. So we will load this data into a data frame by means of the URL of the page. So we will first import pandas as PD. This is always the first step. Then we will define the URL of the page. We'll just copy it from here. So this string consists of the URL of the page that we are trying to load into a data frame. Now we will create the data frame. Please note that we are making use of the read CSV function because essentially this is a CSV file that has been hosted, as can be seen here from the name of the file. And also the sentiments are separated from the tweets by means of comma. So this is essentially a comma separated file that we are trying to load into a pandas data frame. So to this function we will pass the URL of the page, and we will make use of the head function to see the first 5 rows of the data. So we can see there are 2 columns in the data frame. One is for sentiment and one is for the tweet. We will check the information of the data frame by making use of the info function, and we can see that we have 2 columns, and both these columns are having 30,000 instances each, and there are no missing values. Now that we have our data with us, we can start to analyze it. So now we will start with counting the number of words per tweet in our data set. So before we start with counting the number of words, I would like to introduce you to one function named split. This function is used to split a string into a list of strings by means of a separator. Let's see it in action. We will create a string. We can make use of this part of the tweet. So this is our string. Now if to this string we apply the split function, we can see that this string has been splitted into a list of strings. Now these elements of the strings are nothing but the number of words present in this particular string. That is because here the string has been splitted by the spaces, because the default separator in the split function is a space. Now let's say I introduce this hyphen in the string, and now we want to split this string wherever there is a hyphen present. So to the split function, we will pass in the hyphen as the separator. Now we can see that this string has been split on a hyphen. We can introduce one more hyphen here and see how the change has been reflected. Now we have three elements in it, as there were two hyphens, and the string could be broken into three parts. So by making use of the default version of the split function like this, we can actually get a list of words present in a string. We will make use of this concept while counting the number of words. So coming back to the word count, we are generally interested with this content column of the data frame because this contains our tweet. So we will define a function called word count, which takes in a text and returns the length of the list that we obtained by splitting the text. Text is nothing but a string, or in a particular case, the text is a string of tweets. So here we have defined the function. Now we will apply this function on this particular column of the data frame, that is the content column. So we access the content column and we make use of the apply function. Now this function is used to apply any custom made function to a particular column of the data frame, or it can be used for entire data frame as well. So in this particular case here, we are using the apply function for this content column only. The word count function would be applied to each row of the content iteratively. To the apply function, we will pass in the name of the function that we want to apply to this particular column of the data frame. Now if we run it, we see that we get a list of numbers. We see that we get a series of numbers, and these numbers are nothing but the word count of the tweets. We can actually cross check it. Let's access the first tweet of the data frame. Content. So this is the first string that we have, the first tweet. Now to this tweet, if we apply the split function, we will get a list of words present in that particular tweet. And of this list, if we just calculate the length, we can see that there are 18 words present in the first tweet, and the same is being reflected in our solution. So this was one way in which we applied the function by first defining it like this. Like we defined a custom function named word count, which was returning the length of the list containing the words of the tweet as its element. And then we applied this function to the content column. Now we can perform the same process in a slightly different manner by making use of the lambda function instead of defining the function like this. So in that case, we access the content column, and to which we apply the lambda function using the apply function. And here in the apply function, we will pass the lambda function as the argument, in which we get the length of the list after splitting the text. We get series of word counts for each of the tweets that we have. Now we can also find out the max number of words in a tweet using the max function. We see that we have a tweet with 34 words, and this is the maximum number of words a tweet can have in this data set, particular data set. And the same way we can find the minimum number of words in a tweet as well. So we see that the smallest tweet is just having one word. We can also find the average number of words by making use of the main function. And on an average in the data set, we are having 13 words in tweets. We can also visualize it by making use of the plot function. And we want to make a histogram, so we will supply the kind argument as hist, which indicates a histogram. Now if we run the cell, we see that we receive a histogram, and we can see that the number of words in the tweets data set ranges from 0 to 34. So this is how we can calculate the number of words per tweet. The first way was by defining a custom function called word count, which is returning the length of the splitted string, that is the length of the list containing the words in a string. And the other way is by making use of the lambda function, in which we pass in a text to it, and to that text we are applying the split function to get a list of words, and then we are calculating the length of that particular list. So that is how we count the number of words in tweets. In a similar way, we can count the number of characters per tweet as well. We will first consider a simple example to understand how we can count the number of characters in a string. So we will define one string in this. Now we can see that there are three characters present in this string, that are B, E and D. To get a count of the characters in this particular string, we can make use of the length function. So you can see that the resulting value. So we can see that the resulting value is 3, which is equivalent to the number of characters in this string. Now let us say that a string is something like this. Now there are 6 characters that we can see, but if we use the length function on this particular string, then we get a value of 7. Now this is because the length function also considers the space as a character while counting. So in this case, the space is included in the count. In the case when we don't want to include the space in the count, we have to follow a slightly different approach. In that, we will first make use of the split function to break the string into its constituent words, and the resulting list will be stored in this variable called L. So this is a string, and after split, this is the list of words. Now what we want to do is we want to do the exact opposite of what the split function did. That is, we now again want to join these two words together, like we want to concatenate them, and we don't want any separator between them. Like in this case here, the separator between them is space, right? So there is this another function called join, which is the exact opposite of the split function. Now what join does is it takes in a list of words or a list of strings, and then we pass in a separator to it, and it joins these strings in the list by that separator. And if we don't want any separator, then we just give it blank as the separator. Let us just see. Now what I'm doing is I'm just passing this list of words or a list of strings to this join function, and here in this case here we pass in the separators by which we want to join the strings. So we can see that we didn't pass any separator, so there is no separation between the two strings. To see it more clearly, if I would have passed space as a separator, then there would have been a space. If there was a hyphen, then these two would have been concatenated by placing a hyphen between them. And we can actually use any word, any number, anything as the separator, and it will be like this. So in our case, right now, we don't want any separator between them, and this is our resultant string. We will store it into another variable called s3. So now s3 is the resultant string. Now on this string, if we apply the length function, we will be getting the actual count without the spaces. So that is how we can count the characters in a string. If we want to include the space in the count, then we can just directly use the length function over it. But if we don't want to include the space in the count, then we first have to split it and then we have to join it again without any separator. So now that we understand the logic of counting the characters in a string, we can just define a function called character count, which will take in a text, and then we will split the text into its constituent words, and then we will join the resulting list without any separator between them, and the function would return the length of the resultant string. So this is our custom function, and now we can just directly apply it to the content column as we have done in the case of word count. And we can see that we get the character count of each tweet in the dataset. We can also cross-check it by accessing the first tweet and then we will apply the split function to it. So we get a list consisting of each of the words present in the string, and then we will join it. So we have removed the spaces and simply take the length. So we can see that the first tweet contains 74 characters in it when we are not considering the spaces in the count, and in our result, by applying the function, the character count for the first tweet is 74. In the same way as we did in the case of word count, we can find out the tweet, like the maximum number of characters in a tweet in this data set. So the maximum number of characters without including spaces in the tweet is 142, and similarly we can find the minimum number as well, minimum or average, like we did before. So there is only one character present in one of the tweets, and this is the minimum value of the character in this data set. So now we have learned to count the characters. We can do the same thing by the means of lambda functions as well. That is, we'll just have to slightly change this. Instead of taking the length of this plate, we'll actually add the join function in it as well. We don't want to take the max right now. So in this case again, the results are the same. Like it can be done in two ways. One is by making use of the custom function and then applying it to the tweets column. and the other is by making use of the lambda function. The only difference is that here in this apply function only we are defining the function, and here we are defining it separately and then just mentioning the name of the function. Similarly, we can count the number of stop words in the tweets as well. So stop words are basically a set of commonly used words in any language. So stop words are basically a set of commonly used words in any language. While processing text, we wish to remove these stop words from them because it helps to focus on more important words, and we are able to save a lot of memory space, which helps to speed up computation. Since we are just analyzing the text data at this point, we are only interested in finding out how many stop words are present in each tweet. For this, we will be making use of a Python library called NLTK. NLTK is a standard Python library that provides a set of diverse algorithms for an NLP. It is one of the most used libraries and it provides a list of stop words for many languages. Let's see how we can access these stop words from the NLTK library. So, firstly, we'll have to import the library. If you have not previously installed NLTK in your Python environment, then you can simply make use of the pip install command to do that. So here we are importing the NLTK library, and one more thing we need to do is we need to download the Stopwords package provided by it. It can be done in this way. So now the Stopwords package have been downloaded. Now we will import it. So for importing it, we write from nltk.corpus import Stopwords. So now we have imported the stopwords, and the stopwords here contains stopwords for many languages. For example, English, German, Spanish, and so on. So let's see how we can access them. We will store the list of stopwords in a variable called stop. So to get the stopwords for English language, we make to this words function, we pass in the name of the language. And here we can see that we receive a list of stopwords. Let's see how many stopwords are present in this list. 179. Also, we can access the stopwords for various languages. For example, German, Spanish, and so on. So now we have the list of stopwords that we need to count, or so now we have a list of all the stopwords present in the English language that we can use to count the stopwords present in our tweets. So we will try to count the number of stopwords in our first tweet to understand the logic behind the process of counting the stopwords. So we have the first tweet. This is our first tweet. Now what we want to do is we want to split it into a list of words, its constituent words. So now we have a list of words of this particular tweet, like our first tweet. Okay. And we also have this list of stopwords for English language that we have stored in a variable called stop. So now we can write a for loop we'll be counting. So first actually we'll have to initialize our count with the value of 0. Then we will write a for loop for word into it. That is, for each element of this list, which is actually a list of words, if that word is present in the stop words list, then we increment by 1. So we see that there are actually 8 stop words in this particular tweet. We can write the same thing using list comprehension as well. I for, or I should say word for word in tweet if word in stop. Okay, so these are the stop words that are present in this tweet, and if we take the length of this particular list, then we are left with 8, which is the number of stop words present in this particular tweet. So now using this logic, we can just create a function named stopword count, which takes in a text and it splits the text and stores it in a list. And then it calculates, and then it matches the stop words using list comprehension. Word for word in L, word in stop. Okay, we have already defined the stop words list before, and it returns the length of this particular stop words list. And then again, we can just simply apply this function to the content column by making use of the apply function. Dot apply stop word count. So you can see the count of stop words in the first tweet is 8. So it is verified that a function is working properly. And similarly, we can make use of the lambda function as well to perform the same thing as we have done before. I would suggest that you people try it yourself. Now, similarly, we can also count the number of numbers present in a tweet. Number, or let's say digits. So, we make use of the isDigit function for this purpose. Now, using this function, we can determine whether a given string is a digit or alphabets and digits. That is, it helps to distinguish between alphabets and digits. And if a particular string is a digit, then it would return true. Otherwise, it returns as false. So we know that in the first tweet, there are no numeric values. We can just write a list comprehension for this. Word for word in tweet if word dot is digit. So if the word is digit, then we add the word to the list, otherwise we don't. Okay. And then we'll have to take the length of the list and we get 0 because there is no digit present in this tweet. So we can write a function to apply on the content column to count the number of digits in each tweet. Here I am making use of the lambda function to define the function, and you can actually try yourself to write a custom function. So here we'll be taking the length of the word for word in x dot split if word dot is digit. And to make it better understandable, it can be your text or the tweet. So here we are just splitting the text into its constituent list of words, and then we are just matching if the word is a digit or not, and if it is a digit then we are storing it in a list, otherwise we are not. And after this process is done, we are just calculating the length of the resultant list of words, or I should say resultant list of digits. Okay, so now if we apply it on the function case, so we see that hardly any tweet is having numbers in this case, and we can just check this by actually calculating the max and minimum values. So the maximum number of digits present in a particular tweet is 7 and the minimum is 0. So we can say that some of the tweets are actually having numbers in them, but most of them are not having. Okay, maybe we can just plot it and see it. See, so most of them are actually missing any numeric value in it, but some tweets are having digits as well. Similarly, we can calculate the uppercase words as well. Again, we are going to make use of a function called isUpper. So this function helps to distinguish between uppercase and lowercase strings. If a string is all caps, then the isUpper function results true. Otherwise, it results as false. So we write a string all caps. We see that A is not capital, and we make use of the isUpper function, and it returns as false. But let's say if everything was in uppercase, then it would return as. So we can make use of this function to count the number of uppercase words in tweets, if any. Again, we can just simply write the functions lambda text. We'll be performing almost the same thing, word for word in text dot split, which splits the tweet into its constituent words, and then we check if word dot is upper, and we see that some of the tweets are having a few words which are all in caps lock, or we can say which are all in uppercase. So we can also count the number of hashtags in tweets. For this purpose, we will make use of the starts with function. Now, this function returns true if a given string starts with a specified value. For example, let's say this is a hashtag freedom. Okay, and we are applying starts with function to it, and to this we pass the value as at the rate, and if we run it now, so it returns false because this particular string is not starting with at the rate. Okay, and if I pass hash to it, then it returns true. Not only this, let's say this is a string and we want to find out if it starts with S. Okay, so it returns false because this particular string is not starting with small letter s. But if it is s, then it comes as true. So by making use of this function, we can actually count the hashtags, and not just hashtags, we can also count the mentions present in a tweet. So first we will count the hashtags in a string. Again, it is going to be a similar process as we have followed here using the isUpper function and the isDigit function. So what we can do is we'll just directly copy it this time and we'll make the required changes. So for each particular word in a tweet, we want to find if it starts with hash. So we'll just replace this function and we'll pass in the value as hash, and just like that we can calculate the number of hashtags present in a tweet. And in this case, let's just plot it out using the histogram. So we can see almost all the tweets are not having any kind of hashtag present in them, but there are one or two tweets that are actually having some hashtags in it. Similarly, we can just count the number of mentions by passing it at the rate instead of hash. So we see that there are few tweets again which are mentioning someone. Again, we can just plot it out, check. So we can say that in this data set, there are not many hashtags present, but there are ample amount of mentions in here. So this was some of the basic analysis that we can perform on our textual data to familiarize ourselves with it. In this case, we had the tweets data set. So in this particular video, we learned how to calculate the number of words, the number of characters, stop words, and then the number of digits, and the number of uppercase counts, hashtags, and mentions. So we can actually add all this analysis to our data frame to have a better look at the analysis that we have performed. So for that, we'll just be creating new columns. So there it is for word counts. And then what we'll do is we'll just simply assign here this particular lambda function that we have created to count the number of words, or we can just simply assign the result of this one as well. But in this case, I'm making use of lambda function. I'll just show you here. Let's remove the max value, and now we see that we get the word count. In a similar way, we can add the character count as well to the data frame. Here we can make use of this. I just want to show it once. So this is how we can actually do it. And then there is stopword count. Again, we can just apply the function. Let me just quickly check the name of the function. It is actually stopword count. So yes. Then after the stopwords, number or digit count. I'm writing the number count here. For that here, we can just directly give it here. We'll move the plot function. Then uppercase count is there. Then we have hashtag counts. For that, we just change it with starts with. Also, similar to starts with, we have another function named ends with, which matches the string, which matches the end of the string to the specified value. Okay. So, for example, in this case, the starts with function will actually see if the specified value is present at the beginning of the string, and ends with function actually checks at the end of the string the specified value is present or not. So now here mention count. What I'll do is just paste this here at the rate. Now, if I check the data frame, so we have everything here, the word count for each particular tweet, the character counts, stopword counts, the number counts, and all these things. So we can familiarize ourselves with the data like this. One more thing that we can calculate now at this point is the average word length as well. So what we can do is we can define this column average word length, and then we just divide the character count by the number of words. So again, we can just see the average word length of the words in a particular tweet, and then again by making use of this column we can find the average word length in this particular data itself as well. So that is how we can analyze our data to familiarize ourselves with it. We can see that there are these many stopwords, and stopwords needs to be removed. So in reality what we'll be doing is, so we will be removing this many words from the data frame. This will help us to focus more on the important words, and it will help us to speed up the computation process as the data will be comparatively less, and not just removal of stop words, but there are other pre-processing techniques as well that we will be discussing in the upcoming videos. So that was all that we wanted to discuss in this particular video. Please watch out for the next videos in this series, and thank you for watching this.